I'm just interested in to say the VR Club hosts workshops, and then I'm going to play this footage. So
Perfect.
It's not going to be
perfect. Yeah, looks like we've got a pretty small audience today, so bear with me to get this running. But hopefully it'll be cool because the stuff that we are doing is, I think, pretty fun. So, I guess the place I'll start with this talk while things are kind of loading up here. This is I guess for the people on Zoom, let me kind of show this webcam I have here that can help maybe give a better context of the room. But okay, I'm going to try and fly this thing around. Okay, so all right, this is a little drone that we've been playing with. This is a Tello drone. It's a really nice drone for education and research because it's relatively cheap, easy to program, and we can connect to it with Python and figure out how to send commands to it, get a video signal from its camera. So it does have an onboard camera. So this is kind of what we'd call a pretty small, not the smallest drone, but it is one of the smaller types of drones. We also have in our lab some really big drones that you can carry larger payloads with, bigger sensors, more advanced GPS units that can fly for much longer time. But this is kind of a fun one to play around with. One of the projects that we've been trying to work on is to take a drone like this, where we only have one little camera on here, and we don't have a real super accurate positioning system. So one of the challenges that we've been trying to do is to figure out how can we use this as a platform to get a better understanding of our environment. So we might want to be able to build, for instance, a map of our room or of the outdoors, or create a model of the environment or the scene. And so one way we can do that is by stitching images together. We're working on a couple different ways to do it on this limited platform where we only have a single camera and we don't necessarily know where things are. So that starts off on a couple different projects. The one I'm gonna kind of focus on first here uses the HoloLens. So the HoloLens is a cool thing. Let me put it on here. And then I'll feel cool wearing this thing. Okay, so am I still sharing this? Let me pull up just a little bit of a overview slide of what the HoloLens looks like. So the HoloLens is a AR system that's been built by Microsoft as an AR capable device. And so AR, as opposed to VR, as you know, allows for visualizing the real world around you. And so the big difference here is that we can see our environment and we can put holograms into the scene and see them. So I don't know how much experience you guys have with augmented reality, but this was one of the earlier success stories, I think, in augmented reality. And today it's a little less supported. It's not quite clear what the HoloLens future is specifically, but it is definitely a cool platform. And so I'm excited to see where it goes from here. So let me try and turn on a way for you to see what I see here. Also, okay, so the HoloLens itself has a couple different sensors. So it has a front camera, a color camera that you can get a picture from. It has a couple depth sensors on the side that it uses to track the environment around it. Obviously, it has all sorts of IMU and motion sensors, and the image that you see on the front visor is then projected on top of your actual surroundings. And so if you get the environment just right, it can create a pretty convincing illusion that something is sitting right on top of you. I say it's not fully convincing because it's projected light, and so to get the light to match the real illumination of the environment, that doesn't always work. But as a tool to just kind of have a virtual experience is pretty neat. So let me go ahead and try to connect to.
I know, that's why I said.
Figure out.
Be back. Watch some workshop, like the VR hackathon. We're doing AR with drones.
Figure out what my IP address is. Tiger Wi-Fi. While I'm doing this, okay. So reduce the bandwidth a little bit. Okay, cool. Now I'm just gonna have all sorts of cameras streaming. This will be a nice test to see. Pop that out so we can all see what I see. Let me put another view up so you can all kind of see me kind of working here for those of you on Zoom. Okay. So now, this is kind of misleading, but it's cool. The neat thing about the HoloLens specifically is it has a spatial awareness. So it's tracking my hands here, and if you can see, it's got two little dots casting from my hands here. Let me see if it will recognize this surface. Yeah, okay. There's a bit of a delay I see now from these streams, but what it's doing in the background is it's always capturing a sense of the environment, actually, because it's never been in this room before. It'd probably help if I move around and help it match the environment. So I'm going to walk around enough to help it build up some of this room. So when I'm tapping, you can kind of see this display that shows the map of the room that it's picking up from the cameras. Okay, so that's pretty good. Now, the thing that I want to show first, this first little demo, is a way we've been working on to control the Tello drone in the headset. So the headset's actually kind of just a bonus way to control it. You can control it with a lot of different ways. You can control it from your phone. You can control it with Python, from your computer with a joystick, or programmatically. But we're going to try and see if we can control it with the headset. So I've got a script here that I think we can use. Let's see. I should also mention we're using ROS as a way to
a cinnamon bun or what is
together.
it?
So one of the cool things about working in this space is there's a lot of different pieces that you get to try and connect together. So we have the drones, we have the headset, we have a lot of stuff in simulation. We are using both Unity and Unreal Engine for our various simulation platforms, as well as just pure Python, some open 3D tools where we can just look at 3D models with a more Pythonic interface. So let me try running this.
Cookie too.
Yeah. Oh, sorry, turn on the. Oh, no, it's not going to work. What is that? Just, let's see this. Okay, so I'm just kind of walking through everything that I'm doing here. So this didn't work because it couldn't connect to the drone. So the drone actually has a Wi-Fi signal, so I'm going to have to connect to this. And I was thoughtful enough to bring a second Wi-Fi adapter because otherwise I couldn't also be connected to the internet. So hopefully this doesn't mess up too much network settings. I don't know that I've ever tried streaming this before, so we'll see what happens. Able to connect. I guess luckily there's not a whole lot of Wi-Fi interference to it, so that should help. While that's connecting, let me go ahead and, okay, it's connected. Cool. Run this again.
Where am I going?
Okay, so now you get to see the fun steps of debugging when things aren't working. I'm gonna shut off. Shut off.
Try this. Try it. Come on. Okay.
I'm gonna try this battery. Yeah, so the easy way to connect to it is to turn it on and it will broadcast its own Wi-Fi network. And then you can connect to that network. And it should all work on that. But if you want to do more complicated things, there's actually 2 versions of this Tello drone. There's the education version, which costs like an extra $30, but it lets you connect the drone to a router network, and then you can have multiple drones on the same network. Waiting. Okay, let's try this again. I do Wi-Fi. Here we go. Okay. Strong signal. Connecting. Boy, I hope this works. If this doesn't work, I have a couple recorded videos, so when you do a lot of stuff with these hardware devices with network connections, sometimes it's hard to recreate the conditions when it does work, and so you always try to record when it does work. So if this doesn't turn out, we can resort to that. Here we go. Okay. So now we're going to have a picture from the drone. So this window up here is what the drone sees. And so that is being run through Python right now. And we have a script that makes this image now available to a lot of different programs through ROS. So ROS is it stands for the Robot Operating System. And it's a way to connect a lot of sensors and motors and robots, parts that make up robots. You can connect them all together so that they can talk to each other. So actually, if I open up a terminal here and I have to change my directory to set up ROS, and then I can show you what it can do. Okay, so ROS does a lot of things. Let me show you what it's doing right now. That's not going to work because I'm on Windows. And one of the things that it's really meant or designed around is working with Linux. And so since I'm using the HoloLens, we have to do a lot of stuff on Windows. And unfortunately, ROS and Windows don't always play nice together. But that's okay. We can make it work. So ROS is publishing a lot of information that other sensors can connect to. So for instance, we're getting the image available in ROS, and so I can see that in this window here. I'm also getting information about where oh no, I'm not getting any other information in this. I forgot this demo doesn't do that. So let's see if we can pull this up. So I am using an older version of Unity. This is 2019. When we started developing this, there were some growing pains with getting the HoloLens connected up in the toolkit here. So we haven't completely updated our demo to the latest version, but let's see if this works. Okay. So now what I'm doing is I am running Unity, and Unity is connecting to ROS, where our image and our other information is available. And it is now able to project that image from the drone onto a virtual scene here. So I can move around this scene, and I'll explain this in a minute. This is going to be set up in augmented reality. I have a little debug profile up there as well. But now let me see if I can connect to my HoloLens. So one of the cool things about the HoloLens is that we can stream from our desktop to the HoloLens. It's called holo remoting. It's a little different from a native app. A native app would run on the device and it is standalone. So you can run it anywhere without connection to a computer. But you don't have as powerful of a GPU. And so a lot of times what we like to do is run it in this remoting mode. So let me type in my IP address here, 10.759.189.
Hello? Erica, you still there?
He dropped off Zoom for a. They're trying to reconnect.
Okay, I better go. I'm gonna go see one of these workshops here, though. Tell them it's a pretty cool project. Okay.
Okay. You're just joining us. Unity has crashed, so that happens. I want to see if this will work because it should work, but if it doesn't work, I do have video, so we can resort to that if we need to. Okay, so that's definitely connected to the drone. That's good. That's really tiny. Here we go. Okay. Now I got an echo of me talking in the HoloLens too, so I'm gonna just that's what I don't have to hear myself. Okay, so now we are in this virtual scene. Let me use this gem here, this kind of an anchor thing that I created just to allow me to move things around, so I can grab and move this hologram. We have here a couple of controls and a control joystick thing and the image that we get from the drone. So as I turn the drone, you'll see it's got a little of a delay, but it's not too bad. Okay, so I can actually make this a little bit bigger if I want. Let's see if that's coming through. If you can see that on the screen down there. Let me pull up my other camera here so that we can, for those of you watching along, you can kind of see what's going to happen now with the drone. Let me put the drone down on the floor. Sense of what's going to happen. All right, now see if this works. I have a couple buttons here: a takeoff, a land, and an info button. If I push the info button, it tells me the battery. So we're at 85% on this battery. So that's pretty good considering it's been sitting there watching me set everything up. So now for the big test, we're going to try to take off. Look at that. All right, so now the drone is flying. We get the camera feed here. This little control gizmo here is a joystick of sorts that lets me control it. So if I grab that, I can move the drone up and down. If I let go, it stands still. I can turn. Turn back to the right. Move forward. Move backwards. So the video is a little bit delayed. I'm still working on that, but the controls are pretty responsive. So that's the important thing. So this is all working with all of these components tied together. So we've got Python controlling the drone. We've got OpenCV displaying the image, porting that out to ROS. ROS is going into Unity. There's actually a whole bridge step there that has to happen to convert the ROS data into a JSON format that Unity can use with C#. And then Unity is then creating this virtual scene and porting it out to the HoloLens where I can control it and see all these gizmos here. So a lot going on. I'm always happy when it works. And we can try flying this thing around. So fly it over here a little bit. Move some of these gizmos out of the way. I should be able to just kind of walk around, adjust these controls where I like. It's a little bright in this room, so I'm going to adjust the brightness of the screen. Is that showing up on the? It's kind of showing up. It's a little bit hard to see. I can actually, if I want, I can take this image here, project it out onto like a far wall somewhere. You know, use the force. It's a really fun thing to try and do. Okay, so say that that's out there. Now I'm going to fly the drone. Yeah, there, that's cool. Just where this image works. Sometimes it wants to grab and sometimes it doesn't. I think there's maybe a maximum distance that it can do, or some other thing is getting in the way there. Okay, let's try and bring it back. Turn it around. If you ever fly drones, this is one of the harder things to do, is to have it fly towards you because all the controls are reversed. Hopefully I don't crash. Okay. Now when we want to land, we can hit the land button. There it goes. Still working. Wow. Okay. How much time we got left? A little bit. Almost. I think we got time to try the second demo, I think. Okay, so this is our real drone here. In some sense, this is a prototype of what we would like to be able to do with a bigger drone, one that can fly farther. Oh, we got some new guys here. Let me take it off again while it's still up and running. Doubled the size of our audience. So what we're doing here, we've got a Tello drone connected over Wi-Fi to this computer that's running ROS and Python and Unity. It is projecting the image into the HoloLens where I can see it on a virtual screen. I don't know if you can see, I've got a couple windows up on the screen here where you can kind of see the views that I see. Around again. Okay, so I can control this. I can click this button here, take off. And it heard me say take a photo, so it has voice command. So every time I say something that it understands, it will try to do that. And then this little gizmo here lets me control the drone, so I can move it just by moving this thing around. So up, down, left, right, backwards, forward. The image that it projects, I've got it now over on this wall here, the virtual hologram. Oh, you know what happened? It actually went behind the wall, and so it can't pick it up. Oh, my HoloLens battery is low. How much power do I have left? 10%. Okay. Let's think about landing. So I can hit this button to land. And that works. Cool. Okay. And I think it just crashed because I ran out of power. That's so perfect timing. Okay. Any questions on this so far? While I charge this up. Oh, this will have enough juice to do any other demos or not.
I guess what sort of use cases are you thinking of? Like this research might be applied to?
Yeah, that's a great question. I've got some slides here that I can speak to that with. Let me plug this in. Oops. The other one. I had it fully charged. Yes, I did. Okay. Yeah, okay, so now that we're back here, let me pull up some of the slides where we kind of explain what this research is all about. So one of the things that we're trying to do, I guess, shut this down so that we don't have to look at that. We're still sharing screen. Okay, so this is kind of a high level overview of the demo that I was just running here. So you can see in the center here is ROS. ROS is kind of the bridge that ties everything together. It's a robot operating system. It's a message passing framework, so we can have different nodes that produce or consume messages from each other and allow different components to communicate and talk to one another using ROS. And so over on the left, we have AirSim in our Unreal environment. And actually, I don't have it on here, but we can use not just simulated environments here, we can use these real drones too. That's kind of the real motivation, is we want to be able to control these drones in a way that we could tell them where to go automatically. So the highest kind of goal with this is to be able to get this drone to map out this room or outside autonomously, to say launch and have it go up, figure out where it needs to go to build a map of the world and to understand what it sees, and then maybe relay some information to you like, oh, I see there's a person over there, there's a car over there. You know, if you need to map things out or plan a good route to get from one place to another, maybe you can't see over some obstacle, there's a building, or in a outdoor environment, maybe there's you know, a big space that you need to cover. And so the scale of these problems can be pretty big. Actually, I've got a couple videos I can show to that. Before I do though, let me finish explaining what this is really talking about. What we do then is we want to do all of those things, but working with real drones can be difficult because we don't always get them working. You can see it takes a lot of effort to get the real system set up a lot of times, and going out to fly can, you know, be challenging. You don't always have good weather. You have to set things up. You don't necessarily have the right equipment. One of the big things that we often struggle with is having accurate ground truth. So if we're trying to build a map, for instance, we don't necessarily know exactly how far away things are in this real world, but in the simulator, we can know exactly how far away things are. So one of the things we were trying to look at is how to do things in simulation. So using, for instance, the Unreal Engine and AirSim, which is a plugin for that lets us model drones, using those to fly around and create point clouds and understand things, and then look at those point clouds and understand how those work using something like the HoloLens. So yeah, let me kind of briefly talk about this. We came up with this tool, PCSim, Point Cloud Simulator, is kind of the idea here, and that it's able to support a lot of different backends. So we can have a real drone, we can have a simulated drone in Open3D or AirSim, and wherever we're getting our information from, those observations come over ROS into our agent code. And so the agent then gets to build up a mental map understanding of the environment. It gets to figure out where the things are. It gets an image, it gets maybe depth. It might get a segmentation map, you know, labeling where things are, and it gets the position of the drone. These all allow the agent to build up this representation of what it sees, and then use that to figure out where it wants to make the drone go next. And so we can tell it to go back to the environment, hey, go to this position, look at this location, and get this big feedback loop. Let me show a couple of videos though of how this all comes together. So let me So I just showed you the one with the Tello drone. This next one is one that uses AirSim and is all done in simulation. So we've kind of got a similar setup, but this time what we're doing is we're running in a simulator where we can build a point cloud from every image that we get. And so when we get an image from the camera, it projects out every pixel in that image, has a depth associated with it from the simulator. And so we can build up a point cloud and then look at that point cloud in 3D with the HoloLens. And so using kind of a similar control scheme that I was showing with the real drone, we can fly this virtual drone through the scene and build up these observations. And so as we fly around, we can get more and more of these point cloud observations. And looking at them through the HoloLens is pretty neat to do because it looks as though you are seeing this virtual point cloud of the environment just kind of get constructed right in front of you. this thing wasn't out of power, I'd try to show it to you. But we have the video instead, which is probably better because I don't know if I could get it working quite as well as it would be doing in this video. So the cool thing about it also is you can adjust, the size and scale of this map as it's being built. So we can zoom in, zoom out, look at it from all sorts of different angles. So one of the challenges that we have when constructing a map like this is you can't see the whole environment all at once. You have to choose where to go to get your next viewpoint. So as we get one view, you can see some of the backsides of these buildings don't get observed. And here I am adjusting the scale of these points so that you can kind of see through them a little bit more, or let them fill up to look kind of like solid objects. Diving in on this red car because that's something that I'm trying to get a better picture of. And so you can kind of see it there in the model, in the image. And I can zoom in on this car just by manipulating the point cloud to get a better view of it. And you can actually zoom out this point cloud up to like real size 1-to-1 and kind of walk around in this virtual space. Now, obviously, it's just a bunch of points, and so it's not exactly trying to be a photorealistic recreation, but it is kind of neat to see, and it can help you get a sense of the scale of a scene. And it's just kind of fun to play around with too. So that's definitely a fun thing to look at. Okay, I think that's the end of that video. One thing, though, almost out of time here, I think, but one thing else that I wanted to talk about is some of the research that we've been doing with this. So we presented a paper last year on this simulation architecture where we can take this environment and build up observations into a voxel map. So rather than having point clouds, we'll have a voxel map, kind of like Minecraft almost. Every meter gets a color, and we can use that map then to do some kind of analysis to figure out where we want to go. So you can imagine building up a map, one observation at a time, and using that to figure out, okay, where's the edge of this map? Where do I need to extend it? You could think, where have I not seen for a long time? So we could look at the time since we've last observed something to get a better sense of where we might want to go. And so all of these different features and attributes help us pick where we want to go next. And that then controls the drone to, hey, go there. And so we get this big feedback loop of building up a map and using those features to decide where we want to go, and then watching what happens when the agent goes there to see what happens next. So a lot of this framework stuff comes together. And let me just show you this example. So this was a search and rescue simulated mission. Let me make this a little bigger. This was a drone where we simulated it in the Unreal Engine in this outdoor environment. And we have it doing some of this mapping that I was showing before, but it's now aggregating all those point clouds into a voxel map. And I've sped it up here a little bit because it runs for a while. But the scenario is that somebody has been lost, and the only thing we know is that they're somewhere to the south. And so the drone is using all of the mapping information that it has. On the left here is a weighted feature map of where it thinks it should go next. So yellow is the area of this map where it wants to go next. And so as it's flying, it's going to try to extend the map to the south until it can figure out where this person is. So as it's flying through this scene, it's building up the map, putting all these observations in place. This is using kind of a cheating mechanism where we're using the known ground truth, the known depth, and the known position of this person that's lost in the woods there. So here it's got a little box around the person that it sees. So there's a little bit of simulation magic going on to get this to play out. But this is all working towards the ultimate goal of getting this to work with real systems, with real data in real time, where you don't have this nice ground truth that we have in simulation to do the development. Yeah, so that's one little video. Any other questions about this? I think we're kind of officially out of time, but I can play around with a little bit more to see if any of it gets working again.
I mean, there's nothing stopping you from continuing to talk. I think
Yeah.
fine. We're not
Okay.
we're not pressed for really time.
No, we're
like,
not.
I mean, the next thing is origami folding, which you're running. So
Actually, they have to leave because somebody's having a build issue.
oh,
But I think you have the origami paper. But we are happy to have you continue to share your knowledge with us.
yeah,
Sure.
So
Well, we can make kind of an open
I mean, there's plenty of papers.
discussion then. Yeah.
Yeah.
See.
that's pretty interesting. Search and rescue. I know someone who actually works in your lab. I believe Jack Akers, an undergrad. Yeah. Which I'd heard you guys were like, you know, I hadn't heard too much about search and rescue stuff, what you guys were doing.
Yeah, so the stuff that we were doing, it really ties into a lot of the different projects that we're working on. Search and rescue is one of the projects where we are trying to explore how best to design the drone's autonomous behavior such that it actually helps human operators. So right now when people go out and they have that situation, hey, somebody's lost in the woods, we know that they're somewhere to the south, we've got a drone that can help us, you know, search for them. They have to have a person sitting on that drone, flying it back and forth, you know, staring at the screen, waiting for something to come up. And so if we can use some knowledge of the environment to say, oh, well, there's a trail here, there's a river here, you know, there's a cliff over here. And so using all that information together to get some kind of intuition as to where they might have gone. And then let the drone kind of go up, start doing its search pattern on its own, so that you have now that person's not tied up using the drone to help actually search and navigate and actually hike out into the woods. So that's one application that we're looking at. You know, we have some defense contracts with the military where we do things with the drones that they have available. If you have heard of, there's a IVAS headset program where they were putting things like this, the HoloLens, on soldiers as they go out, so that they have more situational awareness on the battlefield. And you know, we do programs with the drones there to see how much of the stuff that we're working on can tie into that system to provide mapping and situational awareness.
Yeah. I had only heard non-specific defense stuff.
Yeah.
Like I can't talk about it. That's all I know.
Yeah, there are things that are, you know, the IVAS program.
Oh, you have more power down.
Yeah.
You have the drone person again.
I can't say a whole lot, but I can basically say that.
The search and rescue sounds really cool.
Yeah. Well, and you know, another part of it is just doing things purely in simulation. So being able to leverage the Unreal Engine, and some of the newer versions of that are so photorealistic now. You know, it's amazing how much you can get out of the simulated engines.
Yeah, like I'm a little bit surprised. Like, wow, it's really interesting idea if you're testing all this in simulation. So it's like, you know, by the time you're at the real world, it should mostly work.
Now, let me see if I can pull up one of these scenes since we're waiting. Having trouble getting everything working on this laptop. So a lot of this has been going on for a couple of years now. We've had various components of this working on different machines. And we have like a desktop machine down in the lab where it all just works, and
Oh, yeah.
no one remembers how it all got installed. And so, I was going through the other day trying to get it all working on this laptop. And so
I've definitely had a little bit of pain getting a real engine up and running compared to Unity.
It's different, but it's pretty nice actually. Once you learn the basics of it. So here's that mountain scene that I was showing in the video. This is actually, one of the nice things about Unreal is, the engine is open source now. So as long as you're not using it for major commercial purposes, you can download and run it for free.
Yeah.
And the assets that you can get, this is a asset pack that we purchased, but it was, maybe, you can find it probably on sale for $40 or so.
Yeah.
And so it's just a really nice way to quickly spin up, a scene like this.
Yeah, I mean, it looks very nice.
So
yeah,
we're
I know Unreal 5 they're adding some more advanced like terrain generation tools. Like they advertise it at like some recent conference or something of like, hey look, we're adding some even more advanced procedural terrain generation tools. Which just you just say I want this stuff and it just makes it. Yeah.
right.
When you generate the point cloud in Unreal in simulation, you're breakcasting to get that essentially.
So yeah, more or less what it's doing is, let me see if I can run this part at least. So when I start the simulation, we use this AirSim plugin, and it has a virtual drone that gives us 3 images in this case. So we have a color image from the camera. We have a segmented image where we have every object gets a different ID so that we can segment things. And then the important one is the depth image. So every pixel then has a depth that comes with it. And so we can then take that one-to-one image correspondence between the color and the depth and project out using the known camera parameters a perfect point cloud.
If you were to like apply that concept to real life, what kind of scanners would you use? I know LiDAR can do that.
Right.
But...
So there's a couple different approaches. LiDAR gives you a really accurate distance, but it's not dense. So you get a scan as it sweeps across, and you get a couple points. You can get a lot of points actually. So usually it's pretty good for a lot of applications for collision avoidance or basic mapping. You'll see it on some cars as they're driving around mapping out streets. So LiDAR is one way to do it. You can do it with stereo cameras. So some of the, if you remember, like the Microsoft Kinect, back with the Xbox, that was one of the early ways that this was done, and it's improved over time. And so you can get little cameras that are mounted with a stereo pair. It's on that headset here, the HoloLens. And most, inside out tracking headsets will do this, not LiDAR based, but photogrammetry. You take 2 images and you know where they came from, and you can find the overlapping features. And so then you can use that to figure out how far away things are using stereo picture matching. That kind of extends to less rigid structure. So if you don't have a fixed baseline where you know exactly how far the cameras are, you can try to figure that out. If you have enough pictures from enough angles, you can do photo reconstruction. You'll see that a lot of times on drones. You can just fly a scene and then take all the images and stitch them together into a nice map. There's a couple apps now. If you wanted to create a 3D model for game design or something, you could take your phone and just kind of scan a chair like this, and it will take a bunch of pictures and do the math to match them up and figure out where they are. If you have LiDAR on your phone, you know, it can be better, but it's not strictly required. And there's another one that's become interesting more recently, is to use neural networks. Okay. Just take a single image, trained over a whole lot of data, but then it learns, okay, from this one single image, I understand, okay, there's kind of a perspective thing here. There's a person that's bigger than that person, so they're probably closer. I know how big people are. And so it uses all the magic of neural networks to figure out how far away things are. And so that's another emerging area of a way to get depth from something like a camera.
On a related note, I was going to ask, how does like the drone stuff tie into like, you know, the computational intelligence specialization, like Dr. Anderson?
Yeah, so for Anderson's lab, his kind of theme, I think, is sensor fusion and understanding. So one of the early reasons that he got a lot of these drones was to be able to fly really fancy sensors over environments, you know, fields, or for agriculture, or for you know, search and rescue type problems. But a lot of it is, or another one of the defense contracts we have is for landmine detection, so they can fly these drones out and try and search for hazardous explosives. So the drones, in some sense, are just kind of a platform to move the sensor around. And I guess there's a couple of ways you could look at it. There's the traditional thing that we've had for a long time, where here's a data set that somebody has collected for you to analyze, and we want you to get as much information out of it as possible. A lot of projects that we've worked on in the past, we have some contractor that's providing the grant, and so they'll have some data set that they want us to better understand. And sometimes we can understand the sensor and fly and collect our own data set, but it's kind of an offline process where we've gone out, we've collected the data, now we have to come in and figure out, okay, where are all of the landmines, or where are all the people, or what is the characteristics of this plant if we're flying over a field that they might be interested in. And so as that's evolved, we've found ways to think about how can we leverage simulation to better understand those sensors. So some of them, like images, are natural fits for simulation. Some of the sensors, like infrared, for instance, you can try to simulate, but there's other physical things that come into play. And so sometimes game engines aren't as you know, robust at simulating other types of sensors besides just color images. They do a lot of fakery. So one of the things we learned is that from most of these game engines, we get a lot of optimizations that are just meant to make a game look good and run at a fast frame rate, but they lose some of the physical reality of it. So if that's an important property of the sensor that you're trying to simulate, then you have to be aware of that. So for instance, like infrared stuff uses heat and reflectance. And so if you have, for instance, a really hot vehicle that moves around and heats up the scene, a lot of that just doesn't get simulated in a game engine like this. So there are some limitations as to what you can simulate, but in general, I think we use them mostly for the color and depth and the scene understanding. But oh, the other half of that question was, okay, so we get a data set that has been provided to us. We could also try to think about, if we were to collect our own data set, how would we want to do it? Would we want to perhaps have the drone or the sensor move in a different pattern from what the person did. So this ties into the scene understanding and being able to figure out where the most interesting parts of your environment or your map are for you to go and explore in more detail. And so then being able to have that feedback control to say, we want to fly to this point and look in this direction. That all kind of ties into this effort, trying to understand the environment a little more.
Do you try to offload some of the processing from the drone, or do you like in real time?
Yeah. So a lot of the drones have different levels of capability. Some of them have a little more onboard computing. The bigger drones, you can put a processor on there to do a little bit of intelligence right on the drone itself. Some of them you almost have to rely on streaming it down and then using that video stream to do some processing on your computer, your big computer, laptop, or probably a laptop, but you could, if it's going to be real time in the field, or some embedded device like a Jetson or one of these development boards, you can do a little more processing on that. It is a challenge to do things in real time. You have to be, considerate of, how big is your image? Can you process a full frame image, or do you need to scale it down into something more manageable? Can you achieve a good frame rate or not? If you are using it for collision avoidance, then it's really important that you have a fast frame rate, that you aren't waiting for your processing to finish before you decide if you're about to hit a wall or something. So,
well, next one is, do you do something like a bunch of small images and then every so often you sample a large image to check for interesting details, or what?
So there's a couple different ways to approach it. The one that we've kind of been drawn to is that you have a constant video stream that you have access to, and you can sample from that stream into a mapped representation. So I like to think of it as like the mental map of the agent. It's like you've observed all of this stuff at this time as it's evolved. And so how do you aggregate it all together into something that you can understand? And you could do it with points and a big point cloud, but that gets back to the real-time question of every image then adds 10,000 points to this point cloud. Eventually you get millions and billions of points. You have to do that more efficiently and process it more effectively. So we're looking at things like voxel spaces, so you can get this hierarchy, this octree representation with the voxel space. It's really an efficient way to represent in a hierarchical way all this data. So there's some other approaches we've considered. So doing things like understanding the spatial relations between significant objects. Like I see that you two are close together and you're kind of behind one another, and you two are over here kind of close together, and there's some distance between this. So being able to, like in a graph form, represent, okay, object, they're near and in this angle in relationship to each other. Is that a way to have a better compression of the information in the scene? And is that more useful if I'm trying to communicate, like have a verbal command to a robot, hey, go behind that person? Like, what does that mean unless you understand where the person is in the scene, or go to the end of the room, or go around the tree, or, so having some semantic understanding of all of the stuff that you see in the scene is good too. Cool. I think this thing wasn't used to streaming and and doing all this stuff at the same time, so that probably drained the battery. a lot faster than I was used to. I probably also didn't have it fully charged. I thought I did. But
The project you showed is pretty interesting. It reminds me a lot of the Capcom project I did. Like Jack Akers was actually on my Capcom team. We did like a VR controlled robots project.
Yeah.
So like we set up a thing where it's like you'd have a kind of general client program on the robot, Java server, and then like a Unity thing talking to the robot and get like a video stream and controls that pop up with the robot telling Unity like, hey, what do I have as like resource? Like, do I have video? Do I have these controls kind of thing? So it's kind of similar to what you're doing. So we didn't use ROS initially because it was kind of like bridging ROS and Unity was not exactly a trivial task.
No, that's very true. ROS and Unity aren't native friends, and honestly, Unreal and ROS are not natively compatible either. So that was one of the first hurdles that we ran into, is just finding a way to bridge all of these components together. So for Unreal, we can use AirSim, which is one way to access all of the information in Unreal and export it to ROS. That's kind of the main reason we were drawn to it. We're finding more recently, though, that we're less satisfied with the image rendering that AirSim is doing. Like, I think we can do better than what it's providing. So we want to improve upon what it's actually putting out.
I was going to ask how challenging is that real-time video streaming, typically between like your headset and drone? Because I know in my captain group, we found it challenging to do that effectively, especially streaming into the game.
Yeah. Yeah, there's just so many factors to it. There's, so for instance, like with the Tello drone here, it's just like a webcam, basically. If you have access to that video stream, you can treat it like any other video stream. Most real drones that have some form of video downlink, you can treat it just like a video stream, like a webcam. And so getting that into your project is just a matter of which method you choose to import that video stream. So the one we picked was to use ROS, which may not be the most latency, optimized way to do it. So you might have seen that there's a pretty significant lag in terms of what we were getting. I haven't quite tracked down where exactly that's coming from, if it's part of ROS or if it's just the way we're doing the Python interface to the drone. But let's see. Yeah, getting the hardware to do what you want can always be a challenge.
I know one challenge we've had is like actually Unity doesn't have a lot of native video decoders that just work with giving you byte data. We had to go track down like a C# script that was like decoded.
Yeah, I did have to jump a little into C# lambs to make this work. So if I can show a little bit of what we had to do. I should this. Just kind of dumped all of these scripts onto this one object, but image subscriber. It is kind of a nice conceptual framework with ROS, because you can, oh, it's not running right now, but you can basically treat it as creating, yes, so this whole thing is pretty brief, but you get a texture,
yeah,
you get the image, you set the texture to be equal to the image. And so every time it receives a new image, it's just going to update that texture.
Also, are you just getting like raw bytes of ROS? You're not actually having anything that's in like a compressed format then?
Right, yeah, so,
Okay, yeah, so the problem my team ran into is we were trying to send compressed video data to Unity.
and then you have to have something that can interpret that.
Yeah, Unity doesn't have that built in. For
Yeah.
some reason, unless you use like a video component that you have to have a URL for.
Yeah,
They don't have like a way to do that by just feeding it a stream of bytes, which was a problem.
yeah, that could be a challenge. We've, you know, with a lot of this development stuff, we find something that works and then figure out how to optimize it and get the frame rate up and going, make sure that you get the basic components in place. And so there's so many moving parts that it's hard to get anything consistently working.
Oh,
unless you
yeah.
have some
Definitely.
baseline. But
I understand that with the stuff we had. I guess one thing super relevant for the people making stuff projects here. How do you feel about Unity versus Unreal from your experience with both of them?
yeah, that's a good question. You know, I like them both for their own strengths. It's interesting. Yeah, people ask, like, why don't we just pick one or the other for this application? Why do we have to use both Unity and Unreal? The main reason for that was we had better pre-built assets and scenes that they just looked better in Unreal for our photogrammetry stuff, trying to make scenes that looked realistic. We found Unreal to be a lot better suited for that type of rendering. But Unity had the better support for the HoloLens and the interaction and being able to create widgets and say, this thing does that. Unity was nice in terms of being able to just organize an AR scene for that. I think, you know, Unity uses C#, which is pretty easy, I think, relatively speaking, to script up. If you just have a real simple thing that you're trying to do, it's got a lot of strengths in that way. Unreal, you can do it in either C++ or Blueprints. I can show you. I don't know if you've used Blueprints before, but when I first found these, that was pretty cool to see. See if there's anything interesting. This is a very interesting find, like actual. Material or something like that. I probably definitely spent a lot more time in Unreal at this point than I have Unity, but I don't feel like I'm an expert at either one. But that's okay, because there's always more to learn. And the nice thing is you can get a lot out of it without being an expert. So you don't have to know everything right from the start.
I know I felt like Unreal has a little bit of like a wall to get started on it. So like it didn't feel as approachable to me as Unity, but I don't know if that's just a side effect of knowing Unity better.
Yeah. Not sure what I'm looking for here. I'm looking for something that I don't have.
One thing I'm not sure about for myself at least is whether once you get used to Unreal, whether it's just as fast to develop stuff in it as Unity, or if it's still a little bit slower, but like there's a reason for it to kind of iterate.
Yeah. I don't know exactly which one I would prefer for developing. Unreal is very well suited, it seems, for creating these 3D type games where you have either a first person environment or a scene that you're trying to render like this. So if your game is the type of game that would exist in some physical virtual space, maybe Unreal is nice to use. It's used for a lot of things besides just game design. So like architecture and simulation,
Yeah.
A lot of them will use this to mock up an environment or a scene.
Yeah, I noticed that typically Unreal out of the box looks a little better. I know Unity has like a high definition render pipeline.
Yeah, I played around with that a little bit. Gosh, this particular project is probably not very instructive in terms of comparing one to the other.
Yeah. Kind of want in general, and then wondering in a general sense for your experience.
There are a lot of just differences between the two. Like you can learn general game design and programming concepts that will translate from one to the other. But a lot of the details don't seem to match up. So like, for instance, one thing that I noticed that Unity allows me to do naturally and very straightforward is to take objects and to put them in like a hierarchy. So like when I grab the little widget that lets me move the controls around, because that control is a parent of all these other things, and it just makes sense that when I move the root, it moves all the other things. Then I can move individual things within that and keep the same hierarchy. There's not a real easy way to do that in Unreal that I've found. So in Unity, you have kind of this hierarchy of all of your scene objects, and they kind of nest together. And if you are transforming one object, you can transform all of its children naturally. In Unreal, basically, all of your objects exist kind of in a pretty flat set, like they are all part of the scene. And I haven't found a good way to like parent objects to say when this thing moves, this thing is a child of that. There are ways to work around and to do it, but it seems much more natural to do it in Unity if that type of thing is something that you need in your game.
I know I've had times where it's super helpful to have a hierarchy meeting, but there are other times when it's like, I want the conceptual hierarchy, but I do not want the actual physical hierarchy where everything's affected. Like I kind of wish there was a way to disconnect that in Unity. Versus Unity is like, if you want one, you have the other. There's like no way to disconnect them. And I'm like, but sometimes I just want to sort things.
Yeah, right. Like I can find like all of the rocks in here. Just well, that's a bad example. The house. Find all of the individual houses, and so each one of these houses is a collection of objects. So I guess I can open this. Yeah, I actually don't do a whole lot of individual modeling. We usually just buy some assets of the whole scene and make whatever modifications we need to do. But if I needed to, for instance, find a good example. If I needed to like take this cart and move it around, I can do that up so that those bags are not parented to the cart. So so I could, I guess, group them together and then create like a group and move the group all as one thing. But I don't think there's a natural way to just parent these objects to the cart, for instance. So maybe there is. Maybe I just don't know Unreal well enough to make these changes, but it's certainly been a fun tool to play around with, and it's been very supportive of our research needs. So that's been the main objective with it, is to have a, because originally, you know, we had, you know, back to the original problem of having the drone, and I want to say, okay, this drone needs to understand its environment, but this doesn't have a depth camera, it just has a color camera. So it's really hard to get anything usable from it in terms of like seeing construction and understanding. We can do it. Actually, I wonder if I can show, this is kind of a cool demo if it will run.
Yeah, how is getting ROS to run on Windows? Because I thought that was like really difficult to do. I don't know if it's gotten easier.
Yeah, that's a good question. I would recommend not using ROS on Windows if possible. And if you do, try to virtualize it, use a Docker image or some other setup where you can still kind of basically have a Linux environment. If you get enough familiarity that you come to realize you have to use it in Windows for something. So like here we needed the HoloLens to run, and so we're kind of stuck using Windows as our main OS. There are ways to use it. So I can install ROS natively on Windows, and it's actually not that bad if you just go through the main instructions and just step by step say install this package manager, set up these configs, and install it. It's honestly relatively straightforward. It takes maybe half hour or so to download and unpack everything, but it's not too bad. The problem is if you're trying to develop anything new with it, compiling any of your scripts under Windows is a pain because it has to go through its own build system, and that can be challenging. But so if you're going to develop your own scripts that you're intending to compile and link into the ROS ecosystem, I would advise trying to stick in a Linux environment as much as possible. Yeah, let me see if this works. Forgot how much battery this had left. I guess I got a couple others in the card.
Oh, go ahead. Keep this. Did you talk to the person who's having no problems? Or? What? Oh. Where is the person?
He's trying to set the search project apparently for the
Oh, is this like related to your research work?
It's
Oh, someone you know. I thought it was someone like with a project for the hackathon.
I thought it was through like
Oh. Oh.
We're going to get the cars ready to.
I don't know if anyone's like told me about prepare a thing for this research presentation. My lab kind of does stuff in the biology building, which kind of do well the life science. We just kind of do our own thing. Somewhat independent of the CS department, but more relevant to bioinformatics stuff. Wait, was that usually like WSL started up with an actual X11 server?
Yeah. Okay. So there's a lot of stuff that we do. Like I said, because doing things on Windows can be tricky. We do a lot of stuff with Docker, and charging this battery. The problem with Docker on Windows and in general is that it usually isn't really meant for GUI applications. So any type of thing that has to have a GUI component needs some like an X11 server or some other way to visualize the output. So we've got ways of doing it with Docker with the X11 forwarding, so you can get a GUI on Windows, and so basically have a full Linux interface. What I'm actually doing here is I've built a Docker container and then exported it to WSL. And so by running it in WSL instead of Docker, I actually have more access to the network interface, which turns out to be helpful when I'm trying to connect to hardware devices like the Tello. So doing it this way, if it works, did I close that? Maybe I closed it. It works. Yeah. There. So I have to preface this by saying this is not something that we made, but this is a package that we found that another group that does more of this research has put together. And this is actually trying to do the mapping using just key points and turning it up, something like that.
As software development goes.
Okay, well, let me try that again. Yeah, if you ever work with real hardware, this probably applies in a lot of contexts, but with hardware especially, I find it'll work one day and then not the next. And it's hard to replicate the conditions when something works.
Oh yeah, definitely.
Even in the lab, I feel like for the intro to VR class, Mizzou, they have a lab like 22 computers in it. They're all the same computers. They all have the same like VR headsets. You're using Quest 2s. It's like some days things work, and some days just like some computers just like random like seems appear to just randomly not want to work with certain students. Something.
Wow, very cool.
Yeah, okay, so this is trying to identify key points in the image and to use those and the correspondences. Let me see if I can fly this. Oh gosh, come on. And centered here. There we go. Okay. No. Okay. I can figure this out. Ow. Oh. Like that. Well, anyway, so what it's doing is it's mapping out the environment just with the camera, so it can figure out key points, and then as the camera moves, it can say, okay, yeah, these key points match to these key points, and so they have this kind of transformation. Therefore, these two image frames are positioned this far apart. Oh. So it's only using the image information to figure out where the camera is in the environment. And so they call it SLAM, so simultaneous localization and mapping, because you can figure out where you are in the environment and also build up a map of the environment.
I'm used to only hearing about SLAM in the context of using like LiDAR robots.
That is, yeah, definitely that's another way to do it. So SLAM is kind of like a big field or topic, and there's lots of approaches to it that you can use. And so one of the ones that I think is really interesting is where you only have a single camera, so visual SLAM.
I definitely like that a bit because I mean, from a cost standpoint, it's more accessible than LiDAR, given that even the cheapest LiDARs are like $100.
Yeah, it's definitely something that I'm interested in, is, you know, trying to get cool things working on cheap hardware. Here we go. Okay, so one of the interesting things about monocular SLAM is it needs the camera to move, otherwise it can't get a different view.
Yeah.
So just rotating like this isn't good. It has to actually physically move. I'm going to try something. See if this works.
So this is kind of like what Tesla's doing on their cars, except, you know, you're going a lot slower and much less likely to just crash into a person 60 miles an hour.
Yeah, right. Okay, here we go. So here's where it thinks the camera has been. Now let's try to take off. One of the reasons I wanted to get this working is because if we actually have a sense of scale in the environment, then I can tell the drone, move to this XYZ position. I don't have to like drive it with my hand manually. So let me do this. It's supposed to go up and down to figure out the scale. Okay. Now, if I enter, say, 2 meters, oh, okay. Okay, so now I can try to put in some absolute coordinates and to get calibrated. Tell it to go forward. See if we can get it to drop down 1 meter. Okay. Go forward. Let's go forward like 1.5. Okay. We can go left. 5. Or is that right? That's left. Okay. We can try to adjust the yaw. Let's by 30 degrees. Okay. Looks like it's trying to build up a good map. I don't know if that's accurate or not. One of the differences here is it's only mapping the key points. So corners and edges of things that are really distinguishable. Let's turn back the other way. Whoa. Trying to be kind of conservative with it because I don't know how robust it is when it starts to lose track. So if I were to turn it like 90 degrees all the way around, it hasn't seen this side of the room at all. And so it's just going to kind of have no sense of where it is. So I'm trying to not do too much of that. Let's see what we can do. All right. Oop. Coming for you. Let me change that. Okay, let's see if we can land this guy. Yeah. What I'd like to be able to do is take something like that, tie it into some of the other stuff that we've been working on so that we could have a sense of how big the environment is when we observe it. So if I wanted to tell the drone to go to a specific point, I could do that in real coordinates. Yeah, that was eventually the
You said that this was someone else's.
Yeah, so let me pull up where
That'd be really cool there.
where you can find this. You go search for Tello ROS ORB-SLAM. So ORB is the image feature that this is based on. This is all developed by you guys. Where are these from? You guys from? I'm trying to remember where they're from. I'm not sure. The trick with this, though, is this. You guys, it seems weird to say that this was a long time ago, but 4 years or 3 years is in this space long enough ago that a lot of these dependencies don't work real well anymore. So getting it installed was kind of a challenge. So for instance, they're using ROS Melodic, which was based on Ubuntu 2018. So if you're not using that particular setup, it can be tricky to get it going.
That is one issue. That is one real big challenge we've had with ROS is the continuous like version migration, where it's like the entire system is super sensitive to your software setup.
Yeah.
When I wish I understood why, because I'm like, this is mostly just a networking layer on top of the OS. Why is it so closely like tied to a particular Ubuntu version?
I think ROS in some sense is one of these like, batteries included packages where it will give you not just the messaging interface, but also a lot of tools.
That's true.
Along with it, like that RQT window with it, lets me like, oh, this is actually populated with useful stuff now. So, for instance, like all this stuff is in ROS, and I can see, all these features. I bet if I go and I do run RViz. RViz is one of my go-to visualization things in ROS.
I'll be right back to the restroom.
I don't know if it's gonna connect to anything. Oh, yeah, okay. And some of these topics. Okay, yeah, so we get the point cloud here.
You're moving things, but we'll take that up, I guess. It flew earlier, but looking at this. My business.
Oh, okay.
Yeah, I was just saying before you left, RViz is kind of my go-to tool for looking at point cloud data with ROS. It's a nice way to.
RViz a little bit before with like
a little bit. Do you think you can like go down and like set up the build? I'm gonna see if I can just like make a semi-transparent plastic.
Yeah. There was somebody else like build a shoe earlier that I was like, oh, I should really go over there after 3, but then I want to stay for this. So yeah, I mean I could make a build and then we don't have any issues. Like that. I'm probably trying to go over there and help them with that. I don't know what the problem is because it's saying yes, the project is trying to run, it's trying to build a PC that works in play with the editor. Try to build it, it doesn't work. When you stick to a face and then like lags really bad. I don't know why. But
yeah, like I've used a little bit with like robotics in St. Louis. I'm part of. We've used ROS quite a bit for a project.
Yeah.
Where our goal is like a robot that would navigate over the science center.
Yeah.
Or at least that was the initial goal.
Have you tried the HoloLens before?
I have briefly.
Yeah. You want to try it?
I mean, I'd be happy to. I went to the MIT Reality hackathon. Stuart and I both went this past January, and like at least one of the Microsoft was not a sponsor at this year's one. They were at the MIT Reality Hack in the past, but there was at least one team that did a hardware project using the HoloLens, also trying to control a robot. So that was pretty interesting.
I'm gonna try a little bit. I'm not sure either.
Quit the Zoom.